Hello friends, welcome back to the channel. Today again we'll be solving a question related to signal system. So the question is as follows. So there is a impulse response h1 of n and impulse again another impulse response h2 of n, and these are connected in series, and an input x of n equal to u of n is given, and then we are asked to find the output. So for solving these kinds of questions there can be many approaches. The easiest approach is to use Laplace. Okay, by Laplace transform also we can do this problem, but we can do this problem by using the convolution properties of impulse. Okay, so what are the properties that we need to remember for this question? The first one is, whenever say a function is there f of n, okay, you are convolving it with del of n, okay, then what you get is f of n. Okay, this is the first property, okay, that we have to use. And the second property is, if say f of n is again convolved with del of say n, but there is some delay of m, okay, so that will be given by m delay. So now the function is again going to be f of n, but the delay is going to be added to that. So we see that the same delay comes to the signal as well. Okay, so what we can do is, we can use these two properties and we can figure out what is going to be the output. So let us proceed. Now first of all, let's see what exactly is asking. So there is a signal, the input signal x of n, and it is given to system 1, that is del of n. Okay, let's say that that gives an output y1 of n. Okay, now from here again an input, and it is given to del of n minus 2, and there we get the output y of n. So he's asking us what is the value of y of n. Okay, so how can this be done with the help of the properties? So let us see. Okay, so again let me once again draw that. So this is our x of n. Now you see here that this is our del of n, and this is our y1 of n, y1 of n, sorry, this is our y1 of n. Now we know that output y1 of n is equal to x of n convolution of del of n. Now we know the property that we have used earlier. This is just going to be x of n, because the convolution with del of n is going to give you the same signal. So we will have this as x of n. Now this is going to be the input to the second system. Okay, so y1 of n is going to be this input to the second system. Okay, system 2 I write it, and then we got y of n. So what we can write for y of n is equal to y1 of n into the the convolution of del of n, del convolution with del of n, and del of n minus 2. Okay, this we can write. Now this is going to be y of n. Again y1 of n is just x of n, just we have calculated. You can see here this is just x of n, just now we calculated. Again it is getting convolved with del of n, okay, minus del of n minus 2. Okay, now again we can use the property of convolution. We can separate these two out. Okay, this, so what we get now is del of n minus 2. Now again you can see, then you can use the property. You can see it is, again this part is just xn, okay, and this part is x of n minus 2, because that there's a delay in the impulse by 2 unit, so same delay is going to come here. But x of n is u of t as given in the question, you can see. So this is equal to, so we can write this is equal to u of n, sorry, u of, I said u of 2, u of n minus u of n minus 2. Okay, so this is what we get. Now you can check that none of the option is like this. Okay, so what we need to do is, now we need to further see what exactly u of n is. So if we plot it pictorially, what we get is, say this is n. Okay, so u of n means this thing. Okay, for every value, oh, it is 1 1 1 1, so it is say 0 1 2 3 4, starts from 0, and this we have to subtract from this value, okay, u of n minus 2, which will start from 2, okay, and it will be 0 otherwhere elsewhere. So it's 0, this is 1 2 3 4 5 6. So these two are going to get subtracted. So when they get subtracted, what we are left with is only this part, 0 and 1, and rest of them get 0, okay, rest of them become 0, okay. So what exactly do we get here? We get this as this individually is del of n, and this individually is del of n plus 1, n minus 1, sorry, this is individually del of n minus 1. So the combined signal is del of n plus del of n minus 1, okay. So this is the answer, okay. So B is the answer. So you can see how to proceed for these kinds of questions, okay. Using the property we have just done it, and this is how you can proceed if you get a problem like this, okay. So thanks for watching.